Hey folks, next two videos we're going to be talking about two different ways to keep lists of information on in your C++ program. So the first way we're going to talk about is kind of the classic way that's been around with us for a very long time called arrays. And then the second video we're going to talk about vectors, which is sort of a newer way in C++ to keep track of lists. So arrays, you're going to find them in every single programming language, and they operate very similarly. What they do is they solve this problem that we have, is that as we get more complicated programs, we often start making lots and lots of variables that are fundamentally the same. Like, here's a bunch of integers that are in a sequence, and it'd be great if I could have a nice way to write parts of my program that selected which one of these values to display given some certain conditions without having to write a million if statements. Or maybe we don't know how many variables we need. It would be great to make have some sort of data structure container that would let us keep track of a lot of different things, so we could sort of hold information as we needed it. So and so that's where this array came along. So a little bit of the history on the array is that, so first how do you make an array? So it looks exactly like another variable. Hey, look, I'm going to make an array of integers, and then I'm going to put these little square brackets down, and I'm going to say that hey, there's going to be five things inside my list, and then I can to say oh, look, the values 1, 2, 3, 4, 5 have been assigned to that list. And then we can do a quick little loop here, and then we can kind of get the power of this is that I can say cout my array at spot I. And what this lets me do is hey, look, I put in the values 1, 2, 3, 4, 5, and instead of having to write cout A, cout B, cout C, and so on and so forth, I can say, hey, let's go through my list, and I'm going to go with my counter, and when I get to the location that each one of these values is, I'll print it out. So you can see there it says 1, 2, 3, 4, 5. Great. Couple of things real quick. You'll notice that I started my counting at 0. Okay. Even though this is the first thing in the list, C++, like a lot of computer science stuff, loves doing counting at 0 because that means all the bits are turned off. And so that's how we're sort of labeling these boxes. So if we think of our sort of traditional variables being a box and we gave it a name, okay, an array is sort of like a filing cabinet. And here's all the filing folders. There's going to be 5 folders in it, and each folder has some things inside of it. So let's say I want to directly access one folder. I could say my array at index 2 is going to be equal to 7. Okay, so remember this is starting counting at 0, so 0, 1, 2, this is actually the third thing, and we're going to change this 3 here is what we're expecting to have changed, and there you go, 1, 2, 7, 4, 5. Okay, so we make arrays any way we want. So I can just say I don't know, Bob's cats. Okay, maybe he's got them all numbered or something. But the nice thing about this is that say I can say, oh, look, he's going to have 10 cats, but I don't really know what their qualities are going to be, so I can just leave them like that, and that'll set them to have no value. And honestly, I'm not necessarily going to have integers of Bob cat. Probably going to have a string with all of Bob's cat's names in them, right? And so if I wanted to, I could start labeling them off, Sam, Tim, Jesse, Aunt Salvador, whatever we want. But this will just give them sort of a null value. So if we want to, for instance, up here, if we got rid of this with integers, you'll see that, hey, look, it went 0, 0, 7. Oh, whoops, because we went here and we actually copied over that third spot again in 0, 0. But the brackets said, hey, let's make every spot default to 0. So So that's really important, the idea of initializing your array. What happens if I don't initialize your array? So let's go back to this. What happens if I maybe accidentally go too far in my array? Oh no, I've gone 15 spots in my array that only has 5 things. Well, weird stuff starts to happen. Okay, so you can see here we start running into uninitialized variable territory. So our variables they're full of junk. We get all sorts of strange behavior. And what you can also get is you can actually get your program will unexpectedly crash. You'll get an error that'll basically say your program stopped responding. And so usually you get that when you try to copy a value into a place that doesn't exist. So there I tried to do this and see how I said I got array action. Oop, it's not popping up on the screen, but I got a little error message saying array action.exe has stopped working. A problem has caused the program to stop working correctly. So you'll get like sort of a crash message if you try to copy values when you're going out of bounds, because it's saying, hey, I can't do any copying. There's no spot there. So we've got to be a little bit careful about what we call out of bounds errors. So what are arrays really great for? They're really great when you know how many things you're going to be sort of keeping track of. Okay, so back in the day, like these took up a little bit of memory. Back in the day when everybody was really memory conscious about their programs, we ran into this issue of like you don't want to accidentally make an array that's too big. So let's say I was going to make a program to keep track of all the addresses that I had. Well, I might say, hey, let's make it 10,000 big. Okay, because man, I know I'm gonna know 10,000 people. Well, back in the day, we cared about that a lot. Just drop a headphone on the keyboard. That's awesome. We worried about that a lot because we don't want to have all of this memory set aside for this thing that might not be used, right? I mean, the average person, maybe they only know 512 people. Okay. So I'm gonna set aside 512 spots. And so old programs, because we were worried about how much memory we were using, would sort of put an upper limit there, and then you'd run into problems when you're like, oh, I'm the one person that knows 513 people. And then your program would run into problems because it didn't allocate enough memory to this list. But if I put in 5,000 people and nobody knows 5,000 people, then I set aside all this memory for this variable that I wasn't using. And back in the day when memory was expensive and, we had, 2K of it instead of, gigs and gigs of it, this meant something to somebody. And they're like, hey, we don't want to, sacrifice the performance or the resources to give that. So it's not quite as big as an issue today. So you can pre-make an array that has a lot of spots. It's just mainly considered bad form, right? Like you make an array the right size for the task that you're doing. If you don't know how big stuff is, that's when we're going to get into vectors. And so the next video is going to talk about vectors and how we can access them. Just kind of a quick note, what are a couple of just like clever ways to use arrays? So one of the ways that often gets used is like what I would call the list feature, right? Oh, look, I might have a list of 100 numbers. We're going to start through and I'm going to, ask for input, right? And I might say, hey, I'm going to go all the way up to 100 numbers. And I might say, cout, enter a number. Okay. And then I'm going to c into my num list at spot ii. And then I might have like if, my num list at spot ii equals -1, then that might be an indication that I wanted to break the loop, like I'm going to stop, okay? So we've done some programs like this, where it's very common we use a flag to say, hey, I'm done, and we break out. So this kind of gives you your traditional list. Like, I asked for a bunch of numbers. I'm going to, keep ticking down. So I'd be like, oh, 5, 7, 8, -1. Or, oops, -2 is okay. -1. Okay, so I got to -1 and it stopped. So now my list would have all the numbers that I had typed in. That's great. It's very popular. Notice that I didn't use all of these extra, sort of spots, right? So then I might want to be keeping track of, how many things did I enter, so on and so forth. So it's a little clumsy because you have all this sort of empty space. And so that's one of the things that vectors are going to help us with later. But the idea, and just in general, that you're going to use like an array as a place to hold a list of numbers, very popular. The other thing that you might really see is that, like, maybe I want to have something specific happen when I enter a number, like to a part of the list. So I want to sort of use it more like a tally sheet, right? So I can make a temporary integer, okay, right here. And I could say enter a number, and I'm going to enter in the temp. And then maybe that temp says, let's do something to that spot in the list. So I could say, my num list at spot temp, maybe I multiply it by 2, okay? Or maybe I add to 2 since they're all 0 to start off with. So this gives us some flexibility. It's like, I want to change locations in the list. So now I'm not caring so much, like, I don't care that they entered in 5 and then 7 and then 5 and then 4. Like, I'm not keeping a list of what has happened. What I really am keeping track of is, like, I started off with all 0s and now I'm manipulating those spots. So that sort of lets you do things like checklists and tallies. And a really common one is, let's say I want to, like, sort of encode some information, and I can put the answers to a bunch of questions in a list, right? So a lot of games, when they generate levels, they have a big list, and then they put in a 0 if it's just like a walking path, and they put in a 1 if it's a grass, and they put in a 2 if it's going to be a mountain, a 3 if it's going to be a tree. And so then they go back to that list, and then they can sort of draw everything they need to draw just by knowing what was in that list. So again, like, it doesn't just have to be, array is collection of information. There's a lot of ways to collect information, and how you represent it is going to be really valuable. So hopefully that is a useful start to your array action, and we'll talk about vectors in the next packet. Cheers.